Hi boys and girls, welcome back to the STEM channel with Mrs. Matthijs. Today I thought we could explore some different liquids and their densities, and in the process make a lava lamp and do a little bit of chemical reactions. In the STEM lab at school, you guys are constantly asking me to do chemical reactions with you guys, and I thought today would be a great day to explore that. So for today's STEM challenge, we are going to need a couple different things. I'll give you a chance to gather them. You're going to need a clear glass container or a clear glass. You're going to need some water. You're going to need some vegetable oil and some food coloring. I have chosen blue to do mine, but you can use red or green. Yellow doesn't work too well because you're not going to be able to see it mixed with the oil. And you're going to need some Alka-Seltzer tablets. I use the generic brand. You don't have to get really expensive. If you have some laying around the house, that's great. If not, you can use aspirin. It doesn't really work as well, but you can try it. I have never used it before, but I've heard it works just as well. So we're going to talk about the density of the different things. Oil and water, when you mix them together, they make salad dressing, Italian salad dressing. We're going to mix them. We're not going to mix them. We're going to see how they actually go into a cup first, and we're going to see what happens. So oil and water, like I said before, when you put them together, you can mix them together. You've heard me say like, oh, you guys go together like oil and water. When you mix, you're great, you're salad dressing, but when you just sit around, you're like oil and water, you don't really do anything. So first thing we're going to do is pour in the water into our cup or our glass. And I've put mine, and you're going to fill that up probably about a quarter of a way up there. I don't know if you can see it. Oh, it looks like my cat's going to join us for a minute. He likes to get on to my computer and sit there because it's warm. Back off. His name is Rue. He thinks he has to be involved in everything I do, but I try to keep him away from this stuff. So the water will sit here in the bottom of my glass. I'm going to let it sit there for a minute just to calm down. And then, oh, yep, there he is. See, everybody? He thinks he's got to be involved. Get back. Next, I'm going to pour in my oil here on the top. Now I'm going to hold my jar steady here. You can see it starts to mix at the bottom. Then I'm going to pour it up. And then it's mixed there. And if you watch, they kind of separate. You can see it's really interesting because the water here is at the bottom and the oil sits on the top, which is really kind of interesting. And you kind of wonder, we kind of made a mixture. We have two separate layers. The water sits at the bottom and the oil sits on the top. And it makes you wonder, why is oil at the top and the water is at the bottom? And I definitely poured more oil in than I did water. And it bodes the question of why? Why does that happen? When I poured more oil in, why is the oil sitting on top when it mixed all together and then it separated? Give you just a quick 10 seconds, maybe 5, just to think about why. Why is that? And the answer is that it has to do with density. The water is more dense than the liquid, not weight, but density. That's why when you can go into the water, we can float, things float on the top, and that's why it has to do with density. So water is more dense than the oil, so the oil sits on top. So we've actually made a mixture. You know, when you can mix things together, you can have a mixture, you can have a solution. When you see the different layers of things, that's called a mixture. When everything, you can't separate them out, that's called a solution. So today we kind of made a mixture because we have different layers of stuff. If I were to pour more water in here, the water would actually go down to the bottom and it would sink. So we have two different mixtures. Next, I'm going to add in some food coloring. Watch what happens. This is pretty cool. The food coloring, just little drops. are going to sink, and you can see the bubbles going down, and the food coloring is going to sink down to the bottom. And I put in about 15, maybe 20 drops of food coloring. It's sinking down to the bottom. And why is that again? Because it's more dense than the liquid that's in there already. So just like the water, it's denser than the food coloring. So again, we can see the different layers that are going on in our jar. Pretty cool. Now comes the fun part. We're going to add in, we'll put a couple more drops of food coloring in there, just because it's fun to watch the bubbles go down. See, they're floating down. Now, what's going to happen is we're going to get a chemical reaction. This Alka-Seltzer tablet is going to react with what's going on here in, I'll back it up a little bit so you can see. Now the water at the bottom is turned kind of blue. You can see the layers at the very bottom is blue, and then it's clear, and then you see that yellowish liquid. So let's see what happens. What's your prediction? I told you it's going to have a reaction of some sort. What do you think is going to happen? What happens? Have you ever watched your mom or grandma, grandpa, dad drop one of these in the water before? Personal experience, what do you think? Let's find out. So we're going to drop one in and have it sink to the bottom because this is kind of heavy, so it is going to sink. Ready? We can't really see it. Oh, there it is. Now, the tablet starts to release. It releases. There it goes. You can see, start to have the Alka-Seltzer tablet releases carbon dioxide and it mixes with the water, and there goes our lava lamp. You can see it's starting to have that lava lamp experience. Just like a lava lamp that we would have. We made our own personal lava lamp. Can you see that? I can hear it fizz. Now it's calmed down a little bit. Because I have quite a bit of water in here, or quite a bit of oil, I'm going to go ahead and drop the other one in there and see what happens. Same thing. So there you go. It's the carbon dioxide or that fizziness that you see in soda. It's going ahead and making our own personal lava lamps. So there you go, boys and girls. A little bit of chemical fun for us today. A little bit of chemical reaction going on. We can make our own personal lava lamps. And as the fizz dies down, what do you think would happen if I added a third one? I don't know. That's the fun with science. You just don't know until you try, right? We'll add one more just to see. As it dies down, you can just do it over again and again. We can have our own personal lava lamp. And as Alka-Seltzer releases the carbon dioxide with the water, it reacts, causing the bubbles to go up and down. As always, boys and girls, when you're going to be doing this, make sure you have mom and dad's permission at home. Just don't go and do it all by yourself. Have some fun with it. I'll talk to you again next week. Next week, look for a really fun, we're going to do a building challenge. Let's see if we can make a lighthouse out of some household materials. Check back next week, boys and girls. Talk to you later. Miss you all. Have fun. Stay safe.